So I'm Raul, and I'm presenting you this environmental sustainability study of acrocomia totai biodiesel. I'd like to thank my co-workers Magil Lapuerta and Yolanda for their effort. First, the table of contents is the following. The first point, a brief introduction. Sorry. I don't know what. A brief introduction of the project. In the second place, a description of the feedstock, acrocomia totai. The third point is the oil and biodiesel characterization. The fourth point is the main part of the slideshow, is the inventory analysis. And finally, the results and the conclusions. As introduced, I'd like to say that normally people think biofuels are sustainable by definition, but that's not a correct thought. You have to deep to know their sustainability. So life cycle assessment is a good tool to know the sustainability, and this considers stages from harvesting to final use. And that's a good tool to know the sustainability of the biofuels. Sorry, but I don't know why the slideshow continues without my click. So in this point, using life cycle assessment, we have in Europe a good frame, the direct. Es que no sé qué pasa, que se pasan solas.
Que se pasan solas. Pues
sí.
Lo tienes en modo habilitado de...
Sí.
Presentación con diapositivas.
A ver.
Aquí, eso,
aquí.
manual. Vale.
Gracias.
Si tenemos que buscar un informático tenemos un problema,
Sorry for the inconveniences, so I'm coming back to my project. As I was telling you, in Europe we have a good frame, the Directive 2009/28/EC, which regulates the sustainability and the use and promotion of renewable energies. So this is a good tool to establish the methodology used in LCA's analysis. So this is a good tool, but always in improving itself. For example, with the proposal of amendment COM 2012, which tried to incentivize the use of new generation biofuels. In Spain, this directive is in the RD Real Decreto 1597, which considers the sustainability of the biofuels. According to the parameters of quality, we have in Europe the EN 590 for the quality of diesel fuel and the EN 40214 for the quality of the biofuels. Second point is the characterization of the feedstock, where acrocomia totai is a palm, a native palm that grows in Paraguay and all over South America. As we can see, the bunch of fruits, and the fruits have different parts. From these fruits, two different oils are obtained. First oil is kernel oil from the endocarp, which is 5% of the fruit. Second oil is pulp oil from the mesocarp, 9% of the fruit. And there are other parts such as exocarp and the pericarp. Also, there are losses due to the changes in humidity and water losses. Third point is the characterization of the oils and the biodiesel. As we can see in the graph, the three different oils, because the mixture is the mix of the two previous oils. The mixture is the oil that we trans-esterify, and its great fatty acids are oleic, palmitic, and lauric. We can see the leverage formula, the molecular weight, and the iodine number are okay. So we trans-esterify this mixture. the biodiesel has these properties. The average formula is the shown one. The molecular weight, cetane number is okay, has a great value. Density is also a normal value. And lower heating value is okay in order to burn this biofuel. But we have to take care with the palmitic acid because in cold weather countries, it could be a problem using this biodiesel. Next point is the main point, as I told you, is the inventory analysis. And here we collected all the data necessary to do this project. As a functional unit, which is the main unit of the project, we used 1 megajoule. Other point is the limits. As temporal limits, we use the 4-year limit because in 2017, the directive changed the emission savings from 35 to 50. So 4 years is a good boundary, and according to the greenhouse gases, 100 years. The spatial boundaries are the Paraguayan boundaries and the European Union boundaries because it is considered this biodiesel to exportation. The methodology is we follow this one given in 2009 directive, and also considering the ISO 40044, which is a norm about sustainability and environment. And according to the directive, the allocation of the energy and the emissions are using the energy content of the products and co-products. The data that have been used in this study comes from ETH, BUAL, Ecoinvent, and Biograce, which are databases for conditions here in Europe. But the impossibility of knowing values from databases of Paraguay allows them to use these databases. The production process data has been provided by Copediosa and energy conversion factors and some emission factors from IDAE. Also, the emissions are measured in CO2 equivalent grams per megajoule of biodiesel. So in this point, the first step of the life cycle is the harvesting. In this stage, the coconuts are harvested using take-out trucks and other manual agricultural tools and transportation vans. All these incomes use electricity from grid, so considering the emission factor of electricity is almost 100% from hydropower plants. The emissions in this stage are really low, value of 4.36 elevated -6, so really low value. In this point, we have to consider the land use changes because it's a key point in the directive. So here, as we can see in first image, is the coconut, and the second one, the same coconut without deforestation or restoring the area. So emissions from LAC, land use change emissions, and ILAC are zero. ILAC emissions are not considered in directive, but here are shown for information purposes. So next stage in the life cycle is the transportation of the fruits. Here we consider the different coconut areas in Paraguay, from where we recollect the coconut, and according to their distance to the extraction plant and the area of these coconuts, we have 35.25 kilometers of transporting distance. These fruits are carried by diesel van, and according to this, the energy associated has that value, and the emissions, that other value. Next stage is the oil extraction, where the fruits are weighed and they pass quality control. They have been stored, and pericap is separated, and next step is key point because sterilization by ultraviolet radiation is important due to the oxidation of these fruits. As we can see, the pressing is using biodiesel as lubricant, so we feed back the system with this biodiesel because it's in cold presses. Some waste products go to pellets, manure manufacturing, and animal feed. The biodiesel produced goes to biodiesel production plant. So these are the emissions, really low because the oil extraction plant, its power supply is by electricity and solar energy panels.
2 minutes, Raúl.
Hmm?
2 minutes.
2 minutes, right. Sorry. Next stage is the transport of the oil and the lubricant, which has this value, this energy value and emission value. This transport is made by tanker truck. At the stage is the biodiesel production, which follows that scheme. And the next step is biodiesel distribution. Scenario 1 considers the full distribution to Paraguay according to this scheme. These are the energy and the emissions. Scenario 2 considers exportation to Spain using the ports and the hydroways in Paraguay, and considering this, these are the values of energy and emissions greater than the previous ones. So final stage in the life cycle is the biodiesel use. Here the Commission assigns a nil emission factor for this biofuel, but the fossil part emissions of the biofuel are considered as methanol burnt. So they are calculated in biodiesel production. So the results, here are the main energy result, the fossil energy ratio. We can see that both values of scenario 1 and 2 are greater than diesel N590. This ratio considers the energy of biodiesel over fossil energy, and next ratio is the energy efficiency, ROI, which considers the biodiesel energy over primary energy invested. Next results are the fossil energy invested according to the different stages. So we can see the saving for scenario 1 is really good, and for scenario 2 is lower because the greater transportation distance, but really good values. The next set of results are the emissions results. We can see the emission from scenario 1 with 11.17 equivalent grams per megajoule, and in the second scenario, 21.59. If we different the result according to the greenhouse gases, we can see that most of the emissions are CO2 and other emissions of methane due to the exhaust of the transportation and the use of methanol. So these are the emission savings, 86-69% for the scenario 1 with respect to diesel, and 21.59 with respect for scenario 2 with respect to diesel. So these emission savings complies with directive. So the conclusions are that this biofuel can be commercialized in Europe, and I would point is that we can use this scheme and this tool to improve the conditions in Paraguay and South America, creating databases, or simply improving the sustainability tools. And this project could be used as the starting point that European Union needs to approve the commercialization of this biofuel. Another conclusion is that this biofuel is closer to second generation biofuels in terms of ROI and emissions. So it's good. It's are okay. And final point is that the use of renewable energy and the use of local local feedstock and avoiding the use of chemical incomes, considering also the profitability of the process, can allow to the producer to decrease the emissions and make the biofuels more sustainable. Thank you.
Okay.